Welcome to another Earth Science podcast. I'm your host, Mr. Buss, and today we'll be talking about types of plate boundaries. For example, what type of boundary is required to give you the Himalayas, mountain ranges, or which type of boundary gives you this instance in Iceland, where the scuba diver is experiencing, or Mount Fuji in Japan. Alright, so let's talk about the situation with the scuba diver first. Technically not really a mid-ocean ridge, but definitely an area where there's rift going on. In this image, a diver swims between the Eurasian and North American plates in a river in Iceland, a lake in Iceland, which is one place in the world where a mid-ocean ridge can be seen on land and in shallow water. Okay, so this is a divergent plate boundary, which means that the plates are moving away from each other at this point. That is referred to as tension or tensional stress on the rocks. The rocks are getting ripped apart, that's tension. And again, these are commonly seen in the mid-ocean ridges. I like to memorize it this way. If there's tension in a relationship, people are going to get torn apart. And same thing with the rocks. Tension in the rocks is ripping the rocks apart. Okay, so for our next plate boundary, let's take a look at the Himalayas next. The Himalayas in Asia are the highest mountains on the planet, and they are mountains, they are not volcanoes. The Himalayas are strictly mountain, a mountain range. They contain Mount Everest, for example. So how did the highest mountains on the planet form? Again, not volcanoes. Well, something has to be pushing this rock up and up and up into the atmosphere. And so the Himalayas are the result of convergent plate boundaries and compressional, a different kind of stress on rocks. Compressional stress where rocks are getting pushed and crushed together. There's actually three types of convergent boundaries that we're going to go over right now, with the Himalayas being one example. Okay, so here we go. The Himalayas are a convergent plate boundary undergoing compressional stress, and specifically it is continental crust smashing into continental crust. When this happens, there's no subduction. The continent just gets pushed up higher and higher and higher, and so you get huge mountain ranges such as the Himalayas when this occurs. Okay, so next would be, I'll go backwards here from 3, 2 to 1. Number 2, when ocean crust meets continental crust, ocean crust will always subduct and go underneath continental crust, and when that happens, volcanoes form due to magma melting and then coming back up. So volcanoes, like this volcano in the Chilean Andes, are due to ocean crust going under something, and in this case, ocean is going under the continent of South America. And so, in an ocean-to-ocean example, one of the ocean crusts has to go underneath the other ocean crust, and you're going to get subduction, and when you get subduction of crust, you get remelting, and you get volcanoes, and so you get Mount Fuji. And Japan is an island arc, that is an ocean-to-ocean convergent type of crust, type of plate boundary. Alright, so this is complex enough, I should go over it one more time. I'm going to go from 1, 2 to 3. Alright, so again, these are convergent plate boundaries experiencing compressional stresses. So you've got things smashing into each other. And number 1 is ocean floor meets ocean floor, and the older, denser crust typically goes under. That process is called subduction, and when that happens, you get remelting of the crust, which causes volcano formation. And again, this is where you get island arcs, such as Japan. Second, ocean to continent. Basically, the same process goes on here. The ocean floor will go under the continental crust in this case. Again, that is also called subduction. And that remelting causes volcanoes, like you see on the west coast of South America, the Andes Mountains. And the third type of convergent plate boundary is continent to continent. And you're going to get landmass smashing into landmass, and you get very, very high mountain ranges, the highest mountains, places on the earth, again, the Himalayas. And you don't get any volcanoes. And so the last type of plate boundary that I want to talk about now, I forgot to put a picture of it initially, but it's the example is the San Andreas Fault in California. You don't get volcanoes at the fault here. You do get earthquakes, and you don't really get mountains either. And the reason for that is really what you're seeing at the San Andreas Fault is you're seeing a transform boundary. And you have shear stress. Think like a pair of scissors or shears. You have one plate moving in one direction, and the plate next to it is just grinding along next to it, causing a shear stress and causing the rock to torque and bend instead of get piled up or get ripped apart. So you're not going to get subduction, so no volcanoes, no compression, no putting mountains up. You just get the land stays kind of level, and the rock experiences a shear stress. So a lot of earthquakes. So here's actually a close-up picture of a rock that's undergone shear stress. You can see how this part of the rock has been pulled and drawn in one direction along the rock here. You might imagine rocks are too brittle to do that, but if the stress is applied slowly over a long period of time, you can actually almost imagine rocks as a really tough Play-Doh. You can actually move them and shape them slowly over time without snapping them. And that concludes our podcast on types of plate boundaries, comparing and contrasting divergent, convergent, and transform boundaries, the types of stresses they experience there, and what types of landforms you might expect to find.